As we continue our journey through the land of exponential functions, we will be finding the intercepts of those functions today, both by hand as well as using your graphing calculator. So the objective that you're writing down today should say, I will be able to graph exponential functions on a graphing calculator and find their x and y intercepts. As soon as you have your title and your objective, go ahead and move on. Some things to remember about the exponential functions. They will always have one y-intercept. But the thing that you need to remember is they may or may not have an x-intercept. So they will have either 0 or 1 x-intercepts. Sometimes a graph will approach the x-axis like this first example, but it will never ever cross it, just like we talked about in 7.2. That one does not have an x-intercept. However, the second visual over here shows that it does cut through the x-axis right here at the point 2, 0. So this one does have an x-intercept, whereas the first one did not. So just remember, there will always be a y-intercept, but there may or may not be one x-intercept. Now here's some basic directions on using your graphing calculator. To find the intercepts of the exponential function, first you need to graph the exponential function, and I will show you how to go to y equals on your calculator, and we're going to type in the equations, but we've got to learn how to type in an exponent. Once you have it in and you hit graph, then you find the y-intercept. You can do that by going to hitting second and then graph, and that takes you to that magic table where all the x and y values are filled out for you. When you want to find the y-intercept, that occurs when x is 0. So when you look on the table and you find where x is 0, that is your y-intercept right there. Now, step 3, to find the x-intercept, this only occurs if the graph does in fact intersect the x-axis. You can use second trace, and then we could trace to find it. You could then go to option 2, press 0 and then enter, and you could set the left and right bounds to have it estimate about where it's at. We can also go ahead and just estimate and then round if necessary. Your x-intercept is written in the form of x as the number, and then 0, because it occurs on the y line where y is 0. It occurs on the x line when y is 0. Once you have those calculator steps written down, make sure you go ahead and grab your graphing calculator, because I'm going to show you some images of things we need to do to get your calculator ready, as well as how to put in the new equations. The first thing I do need to draw your attention to is I need you to go into second y equals, so second stat plot. So if you go into second stat plot, this is the screen that comes up. What I need you to make sure you change from first semester to second semester is you need to turn off all the plotting abilities. We are not going to plot scatter plots anymore. We're going to actually graph the functions. So you need to make sure these are off in order for this to work. Once you have those turned off, then you will click on the y equals button, and it'll bring you to this screen right here. When you go to type in an exponent, so for example, this first one says y equals 2 to the x minus 5. It is very important that you pay attention to details. In this example, do you see that x is the exponent, but the minus 5 is not up there with the exponent? So when we go to type this in, we need to make sure the x is the exponent, but then we get out of the exponent to write the minus 5. So here's what this would look like. You go to y equals, you're going to press 2, so let's say you're here at y equals, you're going to type in a 2, but then to make the exponent, you're going to use this little arrow over here, the upward arrow, so you're going to press the up arrow, and then you can type in your x. But once you are done with the exponent, you need to now hit the right arrow right here, and then it moves you out of the exponent and back down so you can write your minus 5. So now I'm going to redo that in a different color so that you can watch and make sure you've got the process. When you want to get to this screen to write the equation, you hit the y equals button. This screen in front of you comes up. In order to type in 2 to the x and then minus 5, you would type in a 2, the upward caret, and then the x, and then you would hit the right arrow to get out of the exponent, and then the minus and the 5. So go ahead, take a moment, see if you can type that in, and then hit graph. When you do hit graph, you should get something that looks like this. You will notice it does have an x-intercept, which is greater than 2, but less than 3. And it does have a y-intercept right here. The y-intercept occurs, at the point, occurs at the point 0, -4. And it looks like the x-intercept is occurring between 2 and 3, but a little bit closer to 2 and less than 2.5. So I'm going to say it's about 2.3-ish when the y was 0. Now we can be very specific to find those numbers. We know for sure that the y-intercept is at 0, -4. What we do need to estimate is where the x-intercept is. We know the x-intercept occurs when y is 0. So we could do a couple of things. We could hit second graph and go to that magic table and try and find where about y is equal to 0 and see what that x number is. The other option is that you can hit the second trace function. And using that second trace function is a skill that we will practice in class because you do need to set the left and the right bound, so we can practice that. But you will in fact find out that the x-intercept is right at about 2.3. So in your notes, what I would like to see you have written is you've written the equation, you have the table, and you have the graph. Those are the 3 things that I would like to see in your notes for this example. So you don't need to draw the calculator or anything like that, but just make sure you have the table, the equation, and the graph. Now it'll look much cleaner. We have the function y equals 1/3 to the x power. So when you go into your calculator to type this in, you're at the y equals, you're going to type in the parentheses, and then you're going to hit 1 divided by 3, close the parentheses, to the power of, and then the letter x. Once you do that, you should be able to see your graph. You will see it is approaching the x-axis, but it will never quite hit the x-axis. So there is no x-intercept. But as far as the y-intercept, it occurs right here at the point 0, 1. So we do know that we have a y-intercept at 0, 1. The x-intercept does not exist. If we were to try and come up with another point, we could estimate, we could go to our magic table, which is second graph, and we could get several more points. So take a moment in your calculator and see if you can find a few more points. If you did take the time just now to do the y equals, type in the equation, and then second graph to get the magic table, you would find points that look similar to this. When x is 1, the y value is 0.33, where the 3 repeats. And then another point would be when x is 2, it's at about 0.1, where the 1 repeats as well. You could have many other points, but you will notice as the x gets bigger, the y is getting smaller and smaller and smaller. Make sure in your notes you have written the equation, you have a table, and you have a nice graph. When you're ready to move on, go ahead. Now this one gets a little more complicated. When you go to type this one in your calculator, you're going to have the y equals, you're going to do parentheses 1 divided by 4, close the parentheses, use the upward caret, and then type in the x plus 3. Make sure you slide over to the right arrow so that you're out of the exponents. Make sure that looks like an arrow so you know what I'm talking about. You're going to use the arrow on the side of the calculator, and then you'll hit your -6. If you're able to type that in, you should get a graph that looks like this. The x-intercept is just to the left of -4, and the y-intercept is at -6. So we can see that the y-intercept is at -6. The x-intercept looks like it's at about -4.2-ish. If you were to take a moment and look into your calculator and go to the magic table, you could estimate as well. When you do go into the magic table, it will only show you that it's between -4 and -5, and we could see that from the graph. If you, however, do the second trace and then set your left bound just before the intercept and your right bound just after it, you will see it's right at about -4.29, so -4.2 was pretty good. So then if we just want to come up with one more point, if we use that magic table, we could come up with the point 3, -6. There are many points that you can come up with. This is just one that I took right off of the table on my calculator. That could also be calculated by choosing a number to sub in for 0 and then using your order of operations to calculate it. But that is not our goal for today. We do need to identify our x-intercept occurred at the point -4.20, and our y-intercept occurred at the point 0, -6. So make sure in your notes you have the equation, a table with the 2 intercepts as well as 1 additional point to show me you either traced or used the magic table, and there should be a graph. Once you're good, go ahead and move on to our final example for today's notes. When you go to type in this final example, you're going to go to the y equals again. You're going to type in 4, the upward caret to tell it the exponent is x minus 4, but then make sure you use the arrow to the right and then type in your plus 3. So once you take a moment and in your calculator you type that in, do you get a graph that looks awfully similar? Can you tell that this graph is not going to have an x-intercept? It is going to continue and actually only approach at about 3. It is never going to go below 3 on the y-line. So as far as our y-intercept, we can see that it is occurring at the point 0, 3. If you go to second graph on your calculator, you will see it's at 0, 3.0039. That is awfully close to 3. So we'll just go ahead and say the y-intercept is at 3. If I want to find 2 more points, I'm going to again go to that magic table using second graph. Another point I could say is we have the point 4, 4. I am looking at my magic table as I am typing these in on the video, which is something you should be doing as well. One more point would be the point 5, 7. I came up with those by simply using the second graph function on my calculator to give me the table of values. That is our final example. If you can say, I know how to use my calculator, I can take an equation, type it in correctly, and visually get the graph as well as seeing the table. If you feel comfortable that you have been able to accomplish that, then you are done with 7.4 and you are ready to go ahead and start your assignment. If you need to go back and rewatch anything or write down any questions for your teacher, go ahead and do that now. And then when you're ready, go ahead and finish up.